Suppose we were to integrate this integral, x to the 4 e to the negative 3x dx. So whenever we are integrating the integral of this form, so this integral can be written in this form. It's x to the power n e to the kx dx. This is a form that this integral took. So we are going to apply diagonal method. It will be our quicker way to be able to integrate this. So with diagonal method, we are going to be differentiating x to the n the number of times until it becomes 0. So since you differentiate it n plus 1 times, so it depends on your n. So now you are having x to the power 4. So you must differentiate x to the power 4 5 times, because now your n is 4. So you also integrate e to the kx, which is in this case e to the negative 3x 5 times, since you differentiate x to the 4 5 times. Let's begin. Differentiating x to the power 4 for the first time, I have 4x cubed. For the second time, 12x squared. For the third time, 24x. For the fourth time, 24. And for the last time, is 0. I do the same thing with e to the negative 3x. But for this one, I integrate. For the first time, negative 1 over 3e to the power negative 3x. Second time, 1 over 9 e to the power negative 3x. Third time, negative 1 over 27 e to the power negative 3x. Fourth time, 1 over 81 e to the power negative 3x. And for the last time, negative 1 over 243 e to the power negative 3x. Then I'm going to multiply this with this, this with this, this with this, this with this, and this with this. This must go with a positive sign, with a negative sign, positive, negative, positive. This is how the diagonal method works. From here, we have a solution for the integral that we're looking for. So whenever we are integrating x to the power 4 e to the negative 3x dx, we are going to find our solution by saying x to the power 4 multiplies 1 over 3e to the negative 3x. I have negative 1 over 3 x to the power 4 e to the negative 3x plus the product of negative 4x cubed with 1 over 9 e to the negative 3x, which is negative 4 over 9 x cubed e to the negative 3x plus the product of 12x squared with negative 1 over 27 e to the negative 3x, which is minus 4 over 9 x squared e to the power negative 3x plus the product of negative 24x with 1 over 81 e to the negative 3x, which is minus 8 over 27x e to the negative 3x plus the product of 24 with negative 1 over 243 e to the negative 3x, which is minus 8 over 81 e to the negative 3x plus the constant integration. So this is our final answer for this integral. One might be wondering, why did we differentiate x to the 4 until it becomes 0 and integrated e to the negative 3x? We are still applying the same integration by parts method, but now we are making it much simpler, just using this method called a diagonal method. So how did we see that we had to differentiate x to the 4? We use the layette, where L stands for logarithmic, I stand for inverse, A stand for algebraic, T stand for trigonometric, E stand for exponential. Basically, in integration by parts, the function that comes first, of a form that comes first, we always differentiate, and the one that follows, we integrate. So if you can check between x to the 4 and e to the negative 3x, x to the power 4 is an algebraic function, and e to the power negative 3x is an exponential function. That's why we differentiated x to the 4 and integrated e to the negative 3x. So this becomes much simpler.